Morning children. Today we discuss about the absolute maximum and absolute minimum. In the last class we were talking about local maxima and local minima. And this local maxima and local minima we used to find out in the open interval. Now, what is the difference between this absolute maxima and absolute minima and the local maxima and local minima? Absolute maxima and local maxima. See, in the last class we have taken these things. Say, if the function comes here, this is maxima, this is maxima. There are more than one maxima in that cases as per the definition. Among that, which is the highest one, we will be calling it absolute maxima. But there is little deviation from that one. That is, the absolute maxima normally we will be finding out in a closed interval. I just explain with an example. Say fx is equal to x plus 1 and x is in the open interval 0 to 1. A simple example. Now, here, what is the local maximum for this function? Now, when you discuss about this local maxima, see, the interval is 0, open interval 0 to 1. And when we talk about open interval, the 1 is not a point of this interval. It is actually x less than 1 greater than 0. So, if you want to find out the highest value of this one, that means we need to take the highest value of this interval. Say if I say 0.9 is the highest value of x here, then we can say that 0.99 is again the highest, higher than that one. And if you talk about this again, 0.999 is again 2 goes like that. So a highest point for that interval we will not be able to get. So we say that for this open interval for function fx is equal to x plus 2, no local maxima, no local minima will exist. But when you change the interval to an open interval, closed interval 0 to 1, then you can see that the highest value will be 1 plus 2, 3 is the highest value of this function. That it occurs at 1, f of 1. And what is the lowest value of it? F of 0, 0 plus 2. So the lowest value of the function or the minimum value of the function is 2 and maximum value of the function is 3. And why we are able to, how we are able to calculate it is because of it is a closed interval. So this value only we are going to call it as absolute maxima and absolute minima. This is absolute maxima and this is absolute minima. And for finding out this one, we take two theorems without the proof. The statement of the theorem is like this. Suppose f is a continuous function in the interval, say a closed interval. Then it says that the maximum or minimum occurs in this interval. The maximum and minimum occurs in this interval. That is the first theorem. And second theorem is, if f is differentiable in the closed interval AB and C is a point of this interval, then the statement of the theorem is that C is a point in this interval. Then the statement of the theorem is that there exists at least one value where f dash C is equal to 0. If f is a differentiable in a closed interval and C is a belongs to AB, then there exists at least one maxima or minima. I should say that instead of directly quoting this one, there exists at least one maxima or minima in this interval. That is the second theorem. So, of course, the statement will go ahead. The more important part of it is the how to find out the absolute maxima and absolute minima. We have already discussed about how the absolute local maxima and local minima we found out. There we find out there are two methods. One is the first derivative test and second one is the second derivative test. In the first derivative test, what we have done is finding f dot x and equating equal to 0, and we get the turning point or critical point. And then in the left of the turning point and right of the turning point, we find out f dash x, and then we identify which is the maxima and which is the minima point. In the second derivative test, what we do is we find out f dash x and equate equal to 0 and get the turning point, and find out the f2 dash x, and f2 dash x the turning point. We will be checking whether it is a positive and negative. Accordingly we decide which is the maxima and which is the minima. Now in the case of absolute maxima and absolute minima, and based on the last two theorems which I explained, as per the statement, the working rule for finding out the absolute maxima and absolute minima is, the first step we will be solving f dash x is equal to 0 and get the turning point or critical point we will say. So what we will do is, first we find out f dash x and equate equal to 0, solve it to get the turning point. Then find function's value at the turning point and function's value at extreme point. Extreme point. Say the given interval is say AB, then the extreme point is A and B are the extreme point. So what you have to do is find out f dash x and equate equal to 0, get the turning point, and then find the function's value at the turning point and the function's value at the extreme point. If the closed interval given is AB, then extreme point are A and B. That means if I say x0 is one turning point and AB is the interval, we have to find out f of x0 and f of A and f of B. And among these, which is the highest one, that will be called as the maximum value of the function, and which is the lowest one, that will be called as the minimum value of the function. So things are very simple. And why we are able to take that among that one is because the statement of the theorem says that if it is a closed interval, the maxima and the minima happens in that interval at least once. And using that theorem, we can use these steps for finding out the maxima, absolute maxima and absolute minima. Remember, there is little difference that you should not make confused. See, first we find out f dash x and equate equal to 0, get the turning point, and then find the function's value at the turning point. Function's value, not f dash. In the previous all questions we are taking f dash x and f2 dash x. So don't be confused with that one. Find function's value at x0, find its function's value at the left point, find the function's value at the right extreme, and among this, which is the lowest one, that is called the minimum value, and which is the highest one, that is called the maximum value. This is the working rule. And just one example, if I take this, say fx is equal to x square plus 3x minus 9 in an interval say 1, 1, 10 like this. A simple example. So what we do is, first step is we should find out f dash x. F dash x is 2x plus 3. Okay. And let me take this is 0. Then f dash x is equal to 0 implies 2x plus 3 is equal to 0. So you have x is equal to, let me change because I have taken simple example. So 2x minus 3, 2x minus 3 is equal to 0. So x is equal to 3 by 2. And you can see that this 3 by 2 belongs to 0 difference. Okay. So the turning point is 3 by 2. So now we have to find out the function's value at the turning point, function's value at the extreme point, so what is the function's value at 3 by 2? So it is 3 by 2 square minus 3 into 3 by 2 minus 9. And function's value at 0. So that is comes at 0 minus 9 and f of 10. That is 10 square minus 3 into 10 minus 9. So you have to see what is it? It is 9 by 4 and minus 9 by 2 minus 9. So what is the 4 is the LCM 9, then minus 18, then minus 36. Okay, 9 minus 18, okay, 36, 54 minus and minus 45 by 4. And this is minus 9, and this is 100 minus 30 minus 9, 100 minus 39. 100 minus 39 is 61. So which is the lowest one? Minus 45 by 4 is the lowest one. No, sorry. Here how much is? Yes, minus 45 by 4 is the lowest one. And which is the highest one? 61 is the highest. So this is the way. So finding out absolute maximum and absolute minimum is very simple. Find out f dashes, equate equal to 0, get the turning point. Then find the function's value at the turning point and function's value at the extreme points. So I will be sharing some of the questions.